Hey everyone, today we are going to talk about mutations. We are looking at the best practices that there are in GraphQL, and we will look at how we can implement those with hot chocolate. A lot around mutations is really about errors because that's where we have inputs into the system. So you create, for instance, a new book, then you want to validate if all the fields that you provided are valid. And there are other things that could go wrong when invoking a mutation. By the way, we are running workshops at several conferences throughout the next year. So if you want to spend 2 days with Martin and me diving deep into GraphQL concepts and really learning GraphQL from the backend to the front end, then join us. If you like our content, please hit the like and subscribe button. And with this, let's dive in. I already have prepared a little project here that is around cryptocurrencies, and we already have a mutation here. Let's have a look at that. It's down here. It's a watchlist mutation. So essentially a mutation that allows you to put some of your cryptocurrencies on a watchlist. Let's have a look at the GraphQL API with Banana K-pop first. So I'm going here, creating a new document, and then let's head to the schema reference and use the column view. And you can already see that we have here query, mutation, and subscription type. So if I dive in, I can see I have here a mutation, and we will have a look at the code of this mutation. And this mutation at the moment gets in a symbol. You can see this string here and returns a watch list. So this mutation is not done with the GraphQL best practices in mind. But let's first have a look at the code, and then we have a look at what the best practices are and how we can apply them. Okay, I'm heading back here. When we look at this mutation, it's pretty straightforward. We have here a method called add assets to watchlist. This is a mutation type here, and we get passed in the symbol that we want to add to our watchlist. Apart from that, we get some state injected here that is, for instance, a username, so we can determine if somebody is signed in, and we also can find the watch list for this particular user. Further, we have here a DB context, so we can write something to the database. The first things that we do here is validate that our context essentially is okay, user is signed in, and also that the symbol that we provided is correct. If not, we are throwing GraphQL exceptions here. And the next thing that we do is get the watch list from this user. If he or she doesn't have a watch list, we create a new one, and then we add our symbol to the watch list and save everything back to the database. Last but not least, we are returning the watch list here. So let's try that out. So I'm going back to Banana Cake Pop here, and then let's just write a mutation. Okay, this is my mutation here. I can run it. And you can see I get an error here that says user not signed in. And if I think from a front-end perspective, this is really difficult to handle now. So how could I pass that on to the user that is actually using our API on the front-end level? I could display the message here, but then we are talking about localization, so not a good experience. What I could do is actually provide some more properties here. So I could go back to my error here and say, actually, we're using a GraphQL error builder. And with the GraphQL error builder, I can actually add properties to my error. Like, for instance, an error code, or I could even add custom data, like some indicator here. And these properties my front end could use. So let's rerun that query again. And now you can see that we get here these extension data with the code in it and foobar as some additional properties. But this, again, it's not safe for me as a front-end developer because there's no schema behind these errors. This extension field is essentially a map and we can write anything into it, but there's no type safety around that. And this is where we should talk about best practices for GraphQL. And actually, Marc-André, he's working at Netflix, and he worked also at several other GraphQL companies or companies that used GraphQL. And he summarized essentially the various GraphQL error kinds that he found in the wild. There is a typical stage one, and that is what we so far did. Something, we do something here, and then we get a GraphQL error. And then we can also see here the main thing is that we have no schema and nullability. Nullability is because now we are raising an error, we are nulling this out. In our case, let's go back to our GraphQL client here. In our case, this is actually non-nullable. That means the whole result is being deleted. There are a couple of other error stages that have their pros and cons and also their use cases. So the best actually for mutations is down here, the stage 6a. And that's what we want to implement in Hot Chocolate. So the stage 6a has a couple of moving parts to it. It is fully compliant with the relay specification. So the relay specification says that we have an error payload. So we have that here, the create user payload. And the relay specification also says that we have an input into our mutation, which would be called create user input in this case. Apart from that, we have here an array with the user errors, and these are our domain errors, errors that I have for my front-end developers so that they can build their UI components and take these errors into account. The good thing, I have here an array of errors, so I can have multiple errors. And per mutation, I essentially have a union representing all the errors that could happen to my mutation. But if you look at that, it's a lot of work to actually do that. So let's have a look at our code and see how we can implement such a thing and how it actually feels to using it. So this is back in our code. So one thing before we dive into, this actually was really bad before we even looked into the concepts around errors, because we have here a GraphQL exception. And this is GraphQL specific stuff. Actually, often you would have something like a repository or like a service layer or whatever in your business logic that already does all this mutation thing. And in your business logic, then there would be actually an error that you throw that is specific to your business logic. And by the way, if you don't like errors and like result types, I show you, after I showed everything with exceptions, I show you how to do that with result types. So keep watching. So the first thing, let's make this a little bit better from the structure. So the structure is wrong. We want to introduce a payload type here, and we also want to put an input type here. But we actually don't want to invest all the work in our mutation and always implement these types. So what we do with Hot Chocolate is that we can opt into something called the Mutation Conventions. So we go here to our configuration logic, and then we just say add Mutation Conventions. Okay, our server is already rebuilding. We can go back to Banana Cake Pop. So our schema is refreshed, and you can already see that we have here now an issue with the fields. It says that is invalid. So the structure we are using here is invalid. And if we look at our schema reference, we can see that now our mutation returns a payload type, and the payload type at the moment returns a watch list. And also we now have an add asset to watchlist input. So if we go back to our operation here, we can now use the input field here, and then this part is correct. And down here, we actually can use now the payload type, and then we are following already the relay mutation structure. So why an input? So if we work with variables, let's say we have a variable here, and we have more than just one field that we want to pass in, symbol, then we would have to declare for each of these things variables. But now with the input type, the idea is that I just declare one variable, and this one variable allows me now to pass in all the properties in one go. And now the front-end developers can just construct the object wherever in their components and just pass one thing to us, much simpler. So I'm adding down here the variables now, and it's essentially the same query. I can just rerun it. I get the same error at this point. So we aligned the structure, but we still have the shortcoming around errors here. So the next thing is we're going to have a look at errors. So as I said, you actually would have some kind of exception or result type in your business layer. And that means you would have either concrete error objects, validation objects, or you would have concrete exceptions. So let's first have a look at the exceptions. So we can now throw here a concrete exception, like the not authenticated exception here. And down here, we are throwing the unknown asset exception. Okay, while we have now type exceptions, this would actually translate to a worse state. If I run that now here, you can see that I'm getting now an unexpected execution error. That's because we are hiding these exceptions now. We are hiding the details because we don't know if they overexpose. But we actually don't want to GraphQL errors here. We want to make these errors actually proper types in our schema. And the way to do that is that we can add here an annotation. And this error annotation here essentially tells the GraphQL execution engine or the schema builder that these are errors that I want to expose. These are errors that this mutation can throw, and these are domain errors. If we now go back to our schema and rerun this thing, you can see that we actually get watchlist null. So let's have a look at the schema structure, why this is. So now our mutation here returns still the payload. And if we look at the payload, we now have an errors property or errors field here. And we also have the watch list. So the way this works is if it's successful, we actually get the watch list. So that's a mutated watch list. But if it fails, then we get the error back. And the error is actually, you can see here, we only have a type name on it. If I run that, I can see it's a not authenticated error. And that's because this actually is a union here. Let me go back to the schema for a second. And if we actually go into this here, you can see we get the payload type. And then if we go on the errors, we can see it can be these two errors. And now we can actually write some logic here to dig into the errors. So we can, for instance, use an inline fragment here and then say that we want to have certain properties when it's an unknown asset error. In this case, we want to have the symbols. But if we look at this error more closely, let's do that, go in that, you can see that it actually implements an interface called error. And that always has a message. So in our case, we want to handle this error, but we want to be future proof. So if the backend developer at some point introduces a new error, we want to at least get the message. And we can do that because you can see I can actually select from three things here. I can select the general error, that's the interface that both implement, or I can opt into specific error cases here. In my case, I'm going now for the error, and I always want a message. But if it's an asset error, I want to know what symbols were wrong that I provided. So I can rerun that now, and you can see it's the non-authenticated error. And actually that type name here, we can reuse as an error code. So we could alias it to make it nicer, say this is our error code, and then write some select logic on this on the client side. And then we get a message in this case because we didn't do a specific selection on the other error. So this is essentially, if you think about the switch logic in C#, this is our default case. And this is like a specific branch that we are looking into. So if I would now sign in, let's do that. So I'm signed in here as ABC. I'm rerunning that again. I now don't get the not authenticated error. I now get a specific error here that this symbol is invalid. I get the message, but I also get here the symbol that are wrong, and I could now mark that in my UI. Maybe I have a list with symbols there, and I could mark the ones that are invalid red. Okay, this is great, but actually, when I'm not signed in here, I actually have two errors, right? I'm not signed in, but this is also wrong. And this is actually a list. So what we can do with exceptions here is using an aggregate exception. We could aggregate here actually a list. And then if we have this exception, we actually just add it to our list. And then if this list has some entries, then we are throwing them. So let's go and try it out. We go to banana cake pop here. And the schema actually didn't change. So it's just runtime behavior. So we execute that now, and then we get two errors. And that's awesome because if you think about validations where multiple fields may be wrong, you get all the validation errors here in one list. You can dig through the details of this. Maybe there are hints, property names, or field names you refer to. And then the user can fix all these errors and do another mutation. So this is a very good way to handle mutations. So let's have a look at result types, because we could also do that without any exceptions. So instead of these exceptions, we're going to introduce now error types. And I already prepared some here. So I created here two error types, unknown asset error and authenticated error. These are going to be my error types. So what I can do now, instead of providing this guy here, is introducing something called a mutation result. And this kind of is a specific union for our mutation. So at the moment, we are just saying we have a mutation result, and we could still keep these around here. and actually replace them with our types here. So we could say, actually, this guy is returning this or that. Keeping these attributes around could be nice if you have more than 6 or 7 errors. So we could do that. Say this is a mutation result, and you can see you can still return watchlist down here because we implicitly convert this watchlist into now this result. But we now also can return here the errors. So in the error case, we could return a new mutation result here with the errors list. And actually this is now just an object list here. And this is complaining down there because I didn't specify my generic. So this is now a list of errors here. And instead of the exceptions, I'm returning here the error objects now. All right. So this is now using error objects. While we could use the annotations, could also fully qualify that by providing the error cases right into the mutation result here. And this is really up to you, up to your taste, right? It could get really long, and that would make it like not so nice to use. But like for 2 errors, it could still look nice. So it depends on you. We can inspect that from the signature now, or you use the attributes, up to you. The cool thing, if you fully qualify it up here, you actually, if you just returned 1 error, you could just return like the not authenticated error here. And this would be valid because we know this is an error of this mutation result. We would allow that. That would be implicitly converted. Okay, in our case, we have the aggregated error here. And this is now yammering down here because it was the fully qualified mutation result name. The cool thing with .NET, we can just say return new. And then the compiler will actually put all this long type name down there. So you don't have to repeat the full type name here. So with this, we are actually equivalent. We can go back to Banana Cake Pop, rerun that, and it will just work the same way. Just 2 alternatives. You can use the new mutation result, either by qualifying the errors in the mutation result, or by using the attributes still, but using result objects. So I want to have a look at one more aspect here. So while the mutation conventions are good and will get you through most, sometimes you want to opt out of parts of it, but not all of it. For instance, we might want to return our own payload type here. And I already prepared one here. I have this add asset to watchlist payload. And this actually gets in the added symbol and also the watchlist so that I can requery either the full watchlist or the added asset. But then is the problem, how do errors factor in? Do I have to specify here all the errors and stuff like that? And no, you can just override parts of it and we will inspect what parts you have overridden and fill in the things that you forgot. So in this case, we would just return here the add asset to watchlist payload. And then down here, we gonna return that. We feed in the symbol that we got in. Down here, we are now returning the payload and I'm gonna rerun that. And actually this works the same. You can see we get the same error structure here, but now we can actually grab here the added asset directly. Don't have to fetch the full watchlist. We just can query for the asset that has been added. Okay, so let's remove the errors. So I'm signing in and I'm also now providing the correct Bitcoin here. And if I run that, you can see I get here the valid response, the added asset, or the full watchlist that I now have. And if I provide here now the ADA, you can see that this time we get 2 down here, but here just the Cardano that we just added. But the error stays null. But the moment I, for instance, provide wrong symbol, I just get the symbol error. And again, if I logged out as well, I would get that error as well. So very nice from a usage standpoint now. The same, by the way, goes for the input. You could also, like in this case, it's really nice to just add here the symbol. But if you had like 15 properties, you don't want to have 15 arguments. So we could just create a little record here and then construct this input by ourselves. And again, we would recognize that and know that you now provided a valid type here. And this would result in the same schema. We just overrode now parts of it again. You can see it works the same. And then last thing I want to show you is you also have here an annotation. Use mutation conventions. And this allows you, because when you have in the configuration that we have, in the GraphQL configuration here, we actually apply this mutation convention automatically to all mutations. So there are 2 things. You could say that we shouldn't do that. So false, don't apply that to all. And then this attribute that we just added there would essentially be the opt-in. The second part is you could also use it as an opt-out. So if we opt into all, we can opt out on a specific case here. So essentially we say disable and then we would be out. But also we could use that, like, think about, I don't want to have my own payload here. I just want to provide the watch list, but I want not to have the field, the payload field named watch list. It's worse if you had a string here, then we would call the field name string. So if you want to change that, you can override each aspect of the mutation conventions here. In this case, it's the payload field name, and we could call that the updated watch list. We go back to banana cake pop, refresh that. You can see that parts of there are now invalid. We no longer have this because we kicked out our custom payload. And this actually is now renamed to updated watch list. So each part of the mutation convention you can actually override or pre-configure in the overall configuration. This was quite a lot of information. There's actually more, and I will do a follow-up on this and show you how to do that with schema first. So all the people with schema first, I will do a separate video that shows you how to do it with that. With code first, it's actually the same like with annotation based, because you can use the Fluent API and you have the same options that you have with the annotation based approach. I hope this video shows you not only how to do proper mutations from a structure, but also shows you how to expose domain errors to your consumers. One question we commonly get on this is, how would I do such a thing in queries? And I will have another video on that because it's slightly different. Sound off in the comments, give us feedback, what did you like, what not. Also, if you want to help our project, please go to GitHub and give us a GitHub star. This really helps us make our project more visible to a wider community. And with this, I'm out.